Hi students, today we are moving to the second part of lesson 14, chemical effects of electricity. In this, the definition is chemical changes which take place in conducting liquids on passing electric current. So what is the meaning of that? When we are passing the electricity through electrolyte solution, there will be some chemical changes happening. So that is chemical effects of electric current. And what is electrolysis means? When we are doing this process, the chemicals which is present in the electrolyte is dissociated or separated. That is electrolysis process. So you can remember the example, the decomposition of acidified water into hydrogen and oxygen. So when we are passing electricity through acidified water, what is acidified water? We have seen part 1, the water which is added with some amount of acids, diluted hydrochloric acid or any acid, other acids. Thereby it is making water to more conductive to electricity. So hydrogen and oxygen atoms are converted into the form of cation and anion are getting separated. So we are going to do this activity 14.6. It's a very simple activity. In this activity, what is the step we are going to do? We are taking two carbon rods. So if you have any discarded batteries, you remove the cover, you'll be getting a black color thing inside that we are using as electrodes. One as anode, one as cathode. So here we need two carbon rods like that. Before going for doing this activity, we have to clean up these metal caps of carbon rods with the help of a sandpaper. So if you don't have these carbon rods, instead we can use iron nails also as cathode and anode. The next step is we can see here what is the electrolyte used here. You're taking glass or plastic bowl and water. So if you take only water, it is not a strong electrolyte as it contains only very less number of ions. So how can we change this water into a good electrolyte or strong electrolyte? By adding any types of acid solutions. So here lemon juice we are using. What is lemon juice? Citric acid. So some amount of lemon juice is added to water to make it more conductive. So it is conducting more electricity now. So in this experimental setup, you can see the diagram here. We're using electrolytic cell. What is electrolytic cell? An apparatus with all the things ready to conduct electricity. So we need a electrolyte, we need anode, we need cathode, we need copper wires to connect to positive and negative terminal of the battery. Once the setup is ready, the electricity will be passing through this and making the chemical compound which is present in the electrolyte getting separated or dissociated. So here you can see what is dissociated when electricity is passed. Water molecule into hydrogen and oxygen. So what is carbon rod here? Left side and right side you can see carbon rod, but one is written as positive, one is written as negative. What is the reason? Because one is connected to the positive terminal named as positive, which is connected to the negative terminal and named as negative. So like this, we can name the type of electrodes, and positive is named as anodes, negative is named as cathode. And different types of ions are formed by the dissociation. So water molecule, the first one is named as, so if water is, we are taking H2O, right? So it is H2O. The first one always consider with positive charge, second one always with negative charge when dissociation happens and when these atoms are converted to the form of ions. First one is called as hydrogen cation. Second one is called as oxygen anion. So depends on the charge of the ion, it will be moving or attracted towards the oppositely charged electrode. So where does this hydrogen will go? So the hydrogen is having the tendency to go to oppositely charged electrode. So hydrogen will be moving to negative electrode named as cathode. and oxygen is having negative charge and it is an anion will be moving to anode. Like this the reaction happens. So both types of ions are separated from the water molecule. This is the activity 14.6. Same thing will happen if we use iron rod. Move to the next slide. So same thing I have written here. All the steps and inference. What is inference? You read now. The formation of gas bubbles at two carbon electrodes shows that a chemical reaction has taken place in water on passing the electricity, right? So how can you identify these chemical changes? By these four steps. You can identify by these four steps, right? So you can see here oxygen gas is formed at positive electrode, anode. So I told you the reason, oxygen is negative anion, so we'll be moving to positive electrode. Hydrogen is positive, so we'll be moving to cathode. You can see the bubble formation in the solution of electrolyte. That is an indication some reaction has happened. And deposition of metal. Which metal will be seen on electrodes? Carbon. So carbon is deposited at electrodes. The carbon rod will be dissociated, leaving some carbon to the solution. The changes of color of the solution. So the things what is present in the electrolyte is giving particular color, but once after the chemical reaction happens through the electrolysis, what happens? The different components are formed, different types of ions are formed that will be giving different color to the solution. Different chemical changes are happening during this electrolysis process. So these four things you can remember about the chemical changes noticed during this reaction. We move to the next slide. Activity to demonstrate the change in color caused by chemical effect of electric current. So how are you going to do this? The same activity you have studied in one of the activity in part 1. Same setup you are going to do. So what are the things you require? I will show the diagram first. Then it will be easy to understand. Same setup. We're taking one matchbox cardboard. We're taking one compass inside that cardboard. Then the connection is given one side to the positive terminal. Another side we are keeping it free in that case, but here it is connected to one electrode. Okay, so top part is same as one of the activity you studied in part 1. That is matchbox. Then here it is compass needed with the compass for deflection to identify the deflection happened during this reaction and connection to the positive and negative terminal of the battery. Now the difference in this activity is the free ends were connected to dipped into the electrolyte in that case, but here the connection is given to two types of electrodes. So here we are using iron nail as positive and negative electrode, which is connected to the positive terminal as named as, what's the name of the first one? Anode. And second one is named as cathode. That is the difference. So we have these things here for doing this activity. So anode is there, cathode is there, both are iron nails and connection is given. So where does this anode, where anode and cathode are fixed? These are fixed in a potato. So you have to take a potato, peel out the skin, take only the half piece and the part which is not having that outside part we are using the inside part of the potato for immersing or fixing these iron nails. Then the electricity is passing. So the setup is ready now. So what happens now? Just wait minimum 10 to 15 minutes for the chemical reactions happening during this activity. So we can notice after some time the electricity will start flowing. You can see deflection of the needle. And one more thing is noticed, that is chemical reaction happen around the positive electrode. What is the chemical change happened here? The greenish blue spot is identified around the anode. So you can notify two things here. One is deflection of the compass needle. Second one is greenish blue spot formation around the electrode anode, which is positively charged. Move to the next one. Before moving to the next one, First, we should know why these reactions are happened. How does a potato conduct electricity? A potato can conduct electricity because some things which is present inside the potato. What is the content of the potato plus water content is making the potato to dissociate into the form of ions, which is helping to conduct electricity. That is the observation and inference of this reaction. So we'll move to the last slide here in this applications of chemical effects of electric current. So what are the applications? What is the use of this chemical effects of electric current? What are the things you can do with this? First one is electroplating of metals. Electroplating. Second one is purification of metals. Third one is production of certain metals from the ores. Then production of chemical compounds. Last one is decomposition of chemical compounds. So all these five in detail we have to see in the next part. So till now we have completed the second part given in your NCERT book. So whatever things we have discussed today, you have to practice with the help of diagram for better understanding. Thank you.